interpretations of model summary will be the same. The one produced from SPSS, another from Excel, another from Stata, R, Python. Method of interpretation remains the same, right? And I'm sure, friend, have you ever heard of regression analysis or regression line? Do you know what a regression line is? Friend, you can unmute yourself, tuongeongee kidogo, then we dive on this concept. I want to understand whether you know or you are familiar with these concepts.
Well, I think regression analysis
Uh-huh.
measures correlation between variables,
Yes.
and the regression line is the line of correlation.
Yeah,
Um,
or line of the best fit in between variables, you know.
yes.
Yeah, so that is a regression line. So we are going to do a BCD on that concept. Then we can call it a day. Now, introduction to regression analysis. A linear regression. This concept is a statistical technique that is used to model relationship between independent variable and one or more independent variable. Yeah. So in SPSS, linear regression can be performed to analyze the linear association between variables and make predictions based on the observed data. Yeah, and we have statistical uh, theories that comes together with the regression analysis, and one is the assumptions, right? Number one, for simple and multiple regression model to hold, there are some assumptions that we need to make, and you can uh, you can test these assumptions and notice that your data does not meet all of them. But now, what do you do with such a case? Tutaona mbele how we handle cases that does not follow normal, does not follow a specific statistical assumptions, right? And number one, the first assumption that we have is that the sample, we assume, basically we assume that the sample is representative of the population, right? So the second one, we assume that there is a linear relationship between independent variable and independent variable syndrome. Yeah, so we assume that those variables that you want to do regression analysis on are uh, linear. There is a linear relationship between them. Point number three, all the variables are normally distributed, right? And to check for this assumption, we draw histogram of the residuals, right? And you understand the histogram or the shape of that histogram should be equal or should be symmetrical, right? Yeah, that thing should be symmetrical. Another point, we assume that there are no outliers. Yeah, so if there are outliers, they need to be removed, right? And to check, we use a test for detecting those outliers. I'm sure up to now you understand the test that one can use or the graphics that one can use to detect outliers in data. Okay, a question before we proceed. Which is that assumption that one, not assumption, the plot that is used to detect for outlier. I think we did this in Stata. Which graphics do we use to detect for outliers? Frida, do you remember? Mnakumbuka kweli? We use the box plot. Another one is leaf. Leaf what? Priska. Priska. Okay, let's continue. Another thing is that the independent variables are all linearly independent, right? So no variable depends on the other variable, right? So we check for independence. And to check for independence, what do? We plot the independent values against each other and look whether they are correlated, right? So they should be independent. That is, independent variables should be independent. And they should be dependent with the dependent variable, right? And another thing, for multiple regression, there should be at least 5 times as many pairs of data than dependent variables. So these are just some theories that you need to understand. Okay, before we continue, have you downloaded the notes? Do you have the notes together with the data? Today we are doing practical. I will not be presenting alone. Tutatumia laptop ya mmoja wenu. Priska and Frida, have you loaded the data? Priska?
Yes.
Okay, you have the data, right? So tutakuwa tunakiliki hapa, then you share your screen, tunaona venye tunaenda. Priska, what about you? Priska? Priska kuna sisi kweli? Okay, let's continue. Tuendelee. Now, we have an example that we will demonstrate the procedure of regression analysis here. And this is the question. A salesperson for a large car brand, right? Okay, just a minute. Okay, no problem, Priska. But as far as you have the note, make sure you demonstrate what we are doing. So that is it. So let's continue. So let's continue. So this salesperson for a large car brand want to determine whether there is a relationship between an individual's income and the price they pay for a car. As such, the individual's income is the independent variable. The individual's income is the independent variable, and the price variable they pay for a car is the independent variable. Now, this salesperson wants to use this information to determine which car to offer potential customers in new areas where average income is known. Where average income is known. So in SPSS, we need to create this variable. So I'm sure we have created up to. I shared with you the data. Yenye kona income, price. Now, in SPSS statistic, we created two variables so that we could enter our data. We have the income. This is the dependent variable, and the price is the dependent variable, right? So it can also be useful to create another variable called casino to act as chronological case number, but hii achana nayo hatutaitumia pale. And the third variable is used to make it easy for you to eliminate cases. For example, significant outlier that you have identified when checking for assumptions. However, we do not include it in the SPSS statistic procedure, so you are channel now. Now, procedures. How do we come up with the regression analysis output? So this is the data. This is the data. We have income. We have income and price. This is casino. So these are the three columns that we have, or three variables that we have. So you click on analyze regression, then you click on linear, right? So nataka kila mtu akiliki kwake. You click on analyze, then regression. From there you click on linear. Sawa. You click on linear, click linear. From there, I want you to bring price on the dependent variable and income independent. Income, you click on income, then bring it here. So you click on price, sindio? Nimedocument nini hapa? Yes, income, price. So price, we bring it on the dependent variable. Sawa. Kila mtu ako hapo? Frinda, are we okay there?
Yes.
Okay, tumekiliki mpaka hapa sawa. So the next thing, you click on plot, right? So you click on plot and check for normal probability plot, and then click continue. From here you click on plot and mark normal probability plot, and click on continue. So click on continue. Next you click on which is the other output that you want to include. Let's check. Okay, I think it's okay up to that point. From there you can just click on OK. so that you get the output, so that you get the output. So click on OK, and here you are. Here you are. So this is our output, right? Oh, just a minute. Okay, I want as we mark these two boxes, just I want as we mark on plot, we check on normality probability plot and histogram. So and histogram, click on continue and click OK. So and click OK. So this is the plot. Now I want as we start interpreting these outputs. These are regression outputs. We have the model summary. We have the ANOVA. We have the coefficients and residual statistics together with the chart and normal QQ PP plots. So let's see how we interpret these outputs. Number one, on model summary. This is a second table here. This is the model summary, right? This is the model summary. We have R of 0.10. We have R square of 0.0000. So 0.000. Hey, we have adjusted R squared. So this is basically the chart that we want to interpret. So and this model is a poor model, if I may say, or we can just plot a scatter plot of income and the price and see what is happening before we continue to interpret, so that you may understand what we mean by that point. So do you remember how we produce a scatter plot? We want to plot income and the price. Friend, are we together? We want to plot income and the price so that we can check, we can tell whether these two variables are related, right? If there is a relationship between them. So you click on graphics, on graphs, chart builder, then you click on scatter or dot plots. We want to choose this one, so you double click this one. From there, we are dealing with income. So income and price. Price nayo ikue huku. Okay. From there you click OK. Let's get the output. So basically, this is the plot of income together with the price. From this scatter plot, you can tell that income and price, they are not linear. See there? The relationship is not linear at all, right? If the relationship is linear, we expect all this point is equal on a straight line or somehow close to straight line. They form something that makes sense. So Frida, is this concept making sense for you?
Yes. Yes.
So these two variables are not related at all, Cindy. Uh,
Yes.
yeah, that's the reason why we are getting R square of 0.00, Cindy. These are squared. So it means Our model is not accounting for any what? For any values. So let's see the interpretation. This table represents the model summary for a linear regression analysis. And in this particular analysis, the model includes a single predictor variable, that is income, to predict the dependent variable price. So the value of R, which represents the correlation coefficient, is 0.01. So correlation of 1, 1% is very poor, indicating a very weak positive correlation between income and price. This correlation is positive because the value of R is positive, right? So unaweza pata hii ikiwa hata negative. These are the value of R. So you can get it when ikiwa negative. So these are weak positive correlation or relationship between income and price. To make the matter worse, the R square value is 0.000 that indicates the predictor variable income explains none of the variance in the dependent variable called price, in the dependent variable called price. So by this R squared, it means even if you draw line of the best fit, it will not pass through those points. So yeah, the line of best fit will not pass through those points. The adjusted R squared value is negative 0.055. Takes into account the number of predictors and sample size, indicating that the model is not a good fit for the data. So this model is not good fit for the data. We have the standard error, this part here of 194.698. So this is a standard error of the sample estimate, is this one, representing the average distance between the predicted and the actual value of the independent variable. Overall, based on this table alone, the model does not provide a significant explanation of prediction for the variable price using the predictor variable income. So this model hawezi ukafanya, you cannot do, how do we call it, hawezi ukafanya decision based on this model, because this model is very poor, So that's how we define this type of model. Another thing is the ANOVA table. We have the ANOVA table.
A question.
Yes.
So if we enter something like a very strong relationship, maybe the R squared is like around 0.5.
Yes.
What would be like the value of standard error? Is it expected to be smaller than this or bigger than this
Okay. R
if
squared.
the relationship is strong?
If the relationship is strong, we expect the standard error to be very small. So standard error of the estimate, we calculate standard error of estimate based on the predicted point and the actual point.
Okay.
So ni kama, how
Yes.
do we call it? Okay, standard error of estimate, we calculate it based on how distance is the point from the line of the best fit. Unapata the concept now, right? So we expect those values, the standard error of estimate, to be very small if the relationship is very strong. So and we will demonstrate that using a sample,
Yes,
a sample data
because
here. Yeah. So let's continue. So this is the ANOVA table. We have the sum of squares due to regression, degrees of freedom, mean of squares, and I want you to concentrate on the significance value. Significance value here. We have 0.966. So overall, this is the p-value that is used to give summary of the model, of the model. And our p-value is greater than the significance value of 0.05. So it means our model is not effective. Our model is not effective, is not explaining anything. So tukekuwa na a value that is less than 0.05, then it means our model ingekuwa na effect, si ndio? Our model ingekuwa na effect. Na kama tungekuwa na significance value that is less than 0.05, then these values of r squared zinapaswa kukuwa zina explain a reasonable percentage of correlation between a reasonable percentage of relationship between the variables that we consider. So how do we interpret the ANOVA table? This table represents the ANOVA table, ANOVA result for linear regression analysis, and the model consists of one predictor variable, that is income, to predict the independent variable price. And the ANOVA table provides information about the sum of squares, degrees of freedom, blah blah blah, all those things. Now, I want us to concentrate on this part here. Based on this ANOVA table, the regression model does not provide a significant improvement in explaining the variability in the dependent variable price. So this is indicated by non-significant F statistics and high p-value of 0.966. Imagine p-value of almost 1 and p-value of 1. You get your finals, isn't it? That is, p-value is basically the probability, isn't it? And this interpretation makes sense because I want you to be very keen here. Uh, p-value of 96.6%. 96.6%, right? And okay, compare now this value of if you compare that with this one, with the value of r that is 0.1, then hiyo kitu ina make sense sababu 0.1 percent 0.1% is explaining the correlation between those two variables. If we have a correlation of only 1%, then hizo zingine the 96% inakuwa on the opposite side. Then ukisema 96.6% plus 1 inakuwa 97.6. Hiyo ingine iko juu ijaze 100% inakuwa between that 5% error. Hiyo error sasa ya yenye iko kwa probability yenye iko above 95% confidence interval. That's how we interpret this kind of analysis. So any question up to that point? Do you have any question? And John Watch, welcome back. We are doing regression analysis as we wind up with the course. So kutoka leo zitakuwa zimebaki only 2 days, then you give all your project, then from there you will be awarded your certificate. Sawa sawa. Okay, George, karibu. Download this note at your own time, then follow the YouTube video, and utakuwa sawa sawa sawa. So Mr. Oluoch, okay, let's continue. Let's continue now. We have the coefficient table. Where is the coefficient table? Is this one here? This one here. Nataka kuuliza swali before we continue. Sawa sawa. On this coefficient table, why do we have the significant value for income 0.966, and we have the same significant value for the whole regression being the same? Who can tell me the reason? Friend, any idea?
Pardon?
Why are we having on this part of coefficient, we have the significant value for income is 0.966, and from the ANOVA table we have the significant value for regression being the same of 0.966. Why is this value and this one the same?
Which value?
The value in regression, do you see this point here? Can you see this?
Okay.
Kwa regression, kwa ANOVA table,
I think, is it because we have one independent variable?
that's the answer. So that's the answer. So we are getting these values being the same because we have only one independent variable, right? Tungekuwa na 2 or 3, these values won't change. Sawa. Hii na hii inge change. Let's try and see kama zita change. On linear regression, now I want you to include casino on the independent variable and click OK. So the whole regression model iko sasa na ANOVA table of 0.146. So from there the coefficient zinakuja zina change, kila moja inakuwa na yake. Sawa, kila moja inakuwa na yake. So that's the reason why this model yetu hapa ya juu ilikuwa ina explainiwa na only one independent variable. That's the reason why the significance value for regression is the same as the one for income. Sawa. So that is it. Let's continue. Just a minute. So that is it. Let's continue. From this coefficient now, so unaweza andika regression model here. Regression model here is price is equals to income times this value plus the coefficient value of this one here. So and let's see how we interpret this one. So this table represents coefficient for the linear regression analysis, and the model includes a constant term. This is the intercept. Remember, regression model or regression line is represented by y is equals to mx plus c. So the c is the intercept or the constant. Not intercept. C is the constant, which is this value here, and x is the intercept on y. So tunaiandika ikiwa price is equals to in brackets income multiplied by this plus the constant value, which is this one. And from here you can tell that the model is not statistical, or the impact of income on price is not what is not statistically significant. So we have the unstandardized coefficient section, which provides the estimated coefficient for the regression model, and the constant term or the intercept is 23.3 with a standard error of 106.897. So the unstandardized coefficient for the income variable is negative 0.001 with a standard error of this one here. So the standard error of the estimates. These are the errors that we are talking about. I want as we talk of the t. So this t column represents the t values, which measures the significance of the coefficient. So for constant term, the t value is this one, and it is not. And for the income variable, the t is negative 0.044. I want us to concentrate on the significant values, and this column displays the significance levels or the p-values that are associated with each coefficient. So the constant term has a highly significant p-value. So the constant term value is 0.000, which is less than the 0.05. So this value is statistically significant, indicating that the constant value or zero, it is statistically significant from zero, right? And the p-value for income, which is 0.96, is not statistically significant, because the value is greater than the significance value of 0.05. So in summary, this regression model suggests that the constant term has significant effect on the independent variable price. However, income variable does not appear to have significant impact on the price, as indicated by its non-significant coefficient at this high p-value. So hatuwezi tukaconclude statistically that income has effect on price, because the p-value is not less than 0.05. We may understand that concept before we continue. Priska,
Yes, mwalimu.
you may understand what we are doing, how we interpret this.
Yeah.
Yeah, so I think it's simple,
Yeah, I was having a question.
Yes, ask.
Like the data you had sent as like three, in the variable view it has three.
Yes, but
Oh,
we
okay.
have only used
Okay.
two. We have only used two.
The income and the price.
Yes, income and the price. Hii ingine achana naye.
Okay. So when you're doing the regression analysis, like you used it like and regression then linear or
Yes. Then linear. From there, You define the independent variable and the dependent variable, si ndio? Unaweza kuwa na more
Yeah.
than one. Kama hiyo umeona nimedemonstrate na more than one, ili to change the significance value on the ANOVA table, si ndio?
So the dependent was the income or the price?
Independent.
Dependent.
Let's go back. Independent was the income.
Independent was the income.
Yes.
Okay. Yeah.
Then
Okay.
dependent
Thank
was
you.
the price.
Okay. Thank you.
Okay.
I have a concern.
Yes.
What is the difference between 95% confidence level and 5% level of of significance?
Hey, what is the difference between 95% and 5%?
Yes.
That's the question. Okay, others, do you have any idea? Before I answer, nataka kuona tunafikiria aje. Do you have any idea before I respond on that question? Frinda, do you have anything to say about it?
Mm, not really. Huwa zinanichanganya. So I don't know which is which and which we are supposed to use and which one you're not supposed to use.
Uh-huh. Okay. George, Mr. John Joluoch, do you have anything to share about that one? Mr.
No, I don't have
You don't have, eh?
anything. Mi nafuatilia tu, najaribu kuelewa, though nilipata nikiwa nyuma.
Okay. Uh, what is the main difference now between this 95 and 0.005 CDL in statistics or in hypothesis testing? When we are testing or when we are doing calculations, we test on the other part. Okay, how can I answer this one? We have the null hypothesis and the alternative hypothesis, si ndio? Nataka hapo, by the way, hapo ndio answer iko. Frinda, we have the null hypothesis and the alternative hypothesis, si ndio?
Yes.
Which one do we test? Do we test the null hypothesis or the alternative?
The null hypothesis.
No. We don't test the null hypothesis. We do calculations based on the alternative hypothesis. Then we do comments. We comment based on the output that we get from the alternative hypothesis. Sawa sawa. Ndio maana sasa the null hypothesis covers that the confidence we for example nikisema I'm at 95% confidence interval, this student will pass exam. Sawa sawa. So my null hypothesis is this the student will pass
So this will
exam,
not.
si ndio?
Uh-huh.
That's hiyo niko nayo 95%. Now I'm testing this 5% so that my claim remains at 95%. Tunapatana kweli?
So 95% is for the alternative
No,
hypothesis.
not
Uh,
alternative.
uh-huh.
95% is for the null. The 5% nayo ni the okay, 5% ni ya estimate. Tuna estimate something yenye iko above 95, si ndio? Ndio maana unaonanga tukisema when we want to test something at 90% confidence interval, we use the alpha of 0.01, si ndio?
One.
Ni
Yes.
1 or 0.1. Tukisema we are testing
0.1.
Yes, tukisema we are testing at 99% confidence interval, tunatumia alpha of
0.01.
0.001, si ndio?
Yes.
Yeah. So the confidence level the confidence level itself is 100%, which is equivalent to 1. Hiyo ndio probability ya P. So P ranges from 0 to 1, si ndio? In terms of probability, that is the alpha levels, si ndio? So if your significant level is 0.05, sawa sawa, then the corresponding confidence level is 95%.
So, like in our case here,
Uh-huh.
what is supposed to be the null hypothesis?
The null hypothesis for our case here,
Yes.
we have so many null hypotheses here. So the first one is for the ANOVA or for the coefficient. So let's go for the coefficient. See there? The null hypothesis for the coefficient is that income variable, income variable has significant impact on the price. That's the null hypothesis.
Okay.
So
And the alternative?
is the opposite of that one now.
Okay.
So
So the null is supposed to be positive.
yes, generally inapaswa kukuwa positive.
I think that's where I was mixing them.
Yeah.
I understand.
Okay. So that is it. When you do so many examples, ndio hizi vitu zitaingia kwa akili vizuri, those p values. So hata ukiniamisha sana na usiku nitakwambia tu niangalie just the p value, then I tell you what to do. Nikwambie hii iko significant, haina impact on this and this. That's how we interpret data. Sawa sawa. Okay, let's continue. So these are the coefficient. This is for coefficient, and another one is for residual. Let's interpret the predicted values. These are general descriptive statistics, and this table, the residual statistics table, provides the statistics that are related to the residual in the linear regression analysis, and the residual itself represent the differences between the predicted values and the actual observed values of the dependent variable. So unaweza go through this at your own time. Yes, inakuja mpaka hapo. We have this chart. Check at your own time. The use of normal PP plots of regression analysis. This plot is used to plot the observed cumulative probability together with the expected cumulative probability after estimating. You can check at your own time the importance of that plot. So these are plots of regression standardized residual in graphical tool that is used to check or to assess the normality assumption of the residual in a linear model. So the plot compares the observed cumulative distribution function, the CDF, together with the standardized residual with the expected CDF, assuming that data is normally distributed. So by examining these PP plots, one can evaluate whether the residuals follows a normal distribution or deviate from it. So if the plot shows the observed CDF closely aligning with the expected diagonal line, then that one will suggest that the residuals of your estimate follows a normal distribution. On the other hand, if the observed CDF deviates significantly from the diagonal line, then it indicates normal, non-normal distribution of that particular residue. Then, if PP plot can provide, this PP plot actually can provide the insight about the validity of these statistical assumptions underlying the linear regression model departures from the normality in the standardized residual may impact the accuracy of hypothesis testing, confidence intervals, and predictions based on your analysis. So we have another technique that we use in regression analysis to test for normality, and we use okay. Which method did we use to test for normality in data? The most frequently used method to test for normality of data in analysis. Which one? A trial? Tunatumia gani? Yes? Priska, mtu akikwambia umwambie whether the data follows a normal distribution or not, which test will you rely on?
Can somebody use regression?
No, you cannot use regression. Okay, Frinda, a trial? Frinda, you can try. Which method is used to test whether to tell whether whether data is normally distributed or not?
I can't remember.
Okay, do you remember of Shapiro? Shapiro-Wilk? Do you remember that test? We used it in Stata. The Shapiro-Wilk. Then tunatumia the Kolmogorov, Skinst. Okay, let's continue. Acha tuziangalia hapa
I
juu.
only remember the case. I don't
Yeah,
remember the rest.
unakumbuka hizo, si ndio? So hizo imagine imagine hakuna testi zingine utawahi ufanya ya kutest for normality kama si hizo, na hazitawahi change, so you better ukae ukizikumbuka, si ndio? Better ukae ukizikumbuka. So let's see whether our data was normally distributed or not. The normality test, you just click on analyze descriptive statistics, explore, then acha tuingilie hapo tuone tutafika wapi before we end. So click on analyze descriptive statistics, then click on explore. So click on explore. Nataka we move all these three data, all these three variables, I mean, to the dependent list, right? To the dependent list. Then from there, click on statistics. We want descriptives, and unaweza pata. Let's click on outliers also. So this option here, you can adjust the confidence interval for mean. Click on continue and click on plot. click on plot. So I want you to click on histogram. Click on histogram and click on this one here. Normality plot with test. Normality plot with the test. Click on continue. Okay, kila mtu ako hapo. Frinda, awi nani ameachwa? Nani ameachwa nyuma? Frinda, umefika hapo? Umefanya mpaka hapo tumefanya. For the normality test.
Yes.
Umefika mpaka hapo, si ndio? So you mark that box for Instagram and the one for normality test with normality plot with the test. Then from there you just click OK so that you get those particular outputs. So click on continue and click OK. Sawa. Unapatana na nini ya kwanza before we continue? These are the observed values, blah blah blah. These are casino, blah 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 blah, mpaka hapo. So the other one is for price. Ingine ni ya the income. So this is it. So we have the values here. So these are the outputs. So explore. We have the case processing summary and descriptives, right? And descriptives. Utapata we have descriptives for the income. Mpaka ukuje, nataka tukuje hapa chini in this point. We have the skewness of negative 0.486 and kurtosis of negative 0.448. Yes, so we will use these two to tell, not just to understand how that distribution behaves, whether it's leptocutic or the other one. Then from there, we will use the normality test itself, the output now, to do conclusions. So from income, we have skewness and kurtosis here. From price, we have skewness and kurtosis. And from the casino, we have the skewness and kurtosis. We have the extreme values, or values that are deviating from normal distributions of each variable. Utazipata hapo. Then I want us we concentrate on this one here, test of normality. Test of normality. We have Kolmogorov, Smirnov, and Shapiro-Wilk. We have Kolmogorov, Smirnov, and the Shapiro-Wilk. You will notice that we have significant values for each test. So these are two tests combined. From Kolmogorov-Smirnov, the significance values 0.177, which is greater than the significance value. For price the same, for casino the same. Using the Shapiro-Wilk, the significance values, all of them are greater than 0.089. Sawa. Now, how do we interpret those outputs? So, I think you will interpret them at your own time. So these are the plots that you are talking about. Now, this is the table. I want as we interpret this table, interpretation yake iko hapo kwa slide number 19. So this table does not explicitly provide the result of a normality test. However, to assess this normality test, one can consider the skewness and the kurtosis value for each variable. And skewness measures the symmetry of the distribution with a value of 0 indicating perfect symmetry, and positive skewness suggests a longer tail on the right side, right? I'm sure you understand what you mean. Ukichora, how do we call it? Histogram. Then you divide it by 2 from negative point of x and positive point of x. So if we have positive skewness, that's a value from 0 to positive infinity, it will suggest that if that distribution is concentrated more on that point, then it suggests a longer tail on the right side of the particular distribution, while the negative skewness suggests a longer tail on the left side. So kurtosis measures the degree of pickendness or flatness of the distribution. A value of 0 will indicate a normal distribution, and for our case, value of 0, let's see, hakuna pali tuko na value of 0. These values are greater than 0, so that's why our concentration, we will bring it more on the test of normality table. Sawa sawa. So in this case, the income variable is skewness is negative 0.486, suggesting a slight negative pickedness, while the kurtosis is negative 0.448, indicating platycutic distribution. So you will go through this at your own time. Let's interpret our main table now. This one here. This is the test of normality table, and this table represents the result of 2 normality tests. That is the Kolmogorov-Smirnov test and the Shapiro-Wilk test. So these 2 tests does not mean that they are only ones. They are not the only ones that are used to test for normality. We have so many others, but these SPSS will give you these 2. And for the income variable, the Kolmogorov-Smirnov statistic is 0.162. This value here, with these degrees of freedom, and the p-value of 0.177. Similarly for this other one, and value of 0.33, this value here. So now, based on these results, none of the variables exhibit significant departure from normality, as all p-values are above the conventional significance level of 0.05. So this is a direct interpretation. So if these significant values are not greater than 0.05, then the data are not normally distributed. So that's how we check for normality in statistics. And now, if you are doing a research or a project and you notice that your data is not normally distributed, what will happen if you run regression analysis? I want to hear from you. Nataka kusikia kutoka kwenyu. Frinda and Priska, what will happen? What will happen?
The correlation will be very weak.
And will your output be correct?
No.
Okay, I want you to go and research more on what happens if you apply regression analysis on data that is not normally distributed. What are the repercussions, right? And zitakusaidia in your future jobs, so or in your future writing, or palitoi kutana na regression analysis. From there, regression analysis is parametric, right? Which is the alternative method that we can use to replace parametric. Now tunatumia nani parametric, right? which is the best parametric method that can replace regression analysis if the data does not follow normal distribution. Sasa ende utafute hizo at your own time. Do you have any question? Any question up to that point? So these are the, you can tell the distributions are not symmetrical, sindio? Zinafaa kukuwa na bell shaped, sindio? So this is income price and the other one is histogram, so they are not symmetrical at all. So the data is not normally distributed. Do you have any question? Ama tumalizie hapo. So the content is for today is over. Priska, any question?
Yes, you have said like we research on what happens if you use regression analysis for the data that is not
normally
well
distributed.
distributed.
Data that is not normally distributed. And remember, normality test is one of the major assumption for regression analysis. So.
Okay.
Yeah. So actually, normality test is the main assumption. But now, what happens if I ignore this assumption and do regression analysis? So research on that. So.
Yeah.
Okay. So
Kindly, can you share the screen that you started so I can see where I was left behind?
this one,
Yeah, those graphs is what I did not hear. The histogram is what I did not do.
histogram.
Were you doing the
Yes.
price alone or income versus price? The histogram.
This part here. Ziko hapa kwa
Was it for, yeah.
ziko hapa. Si unaona ya for example hapa kwa income kuna histogram yake, kuna hii normal QQ plot, kuna this one other, this other for outlier, then ukikuja kwa price unakuta yake hapo, unakuja kwa expected bla 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 mpaka kwa that one, then unakuja kwa casino. Sawa.
Okay, the y-axis, the frequency.
Hiyo the output.
Do we have
No,
it?
you don't have to define. This software will give it for you for free. Sawa.
Uh-huh.
Yeah. So hakuna umeona pale tuna define these things? No, si ndio? Hizo vitu, these graphs
Okay.
tumezipata hapa by the way. Ukuje kwa descriptives explore, ukuje hapa kwa plots. Sawa. You just mark histogram. Sawa?
Yeah.
You just mark histogram and mark normality plot with the test. Ukifinya continue na click okay, hizo vitu zote zitatoka by default.
Yeah.
Sawa. Sura zimetoka tu.
Sawa. Thank you.
Okay, welcome.
Mm.
Si tupatane kesho. Mkuwe na usiku mwema. Good night.